Hello everyone. There is no satisfactory explanation for some strange behaviors of fundamental particles. But I offer you the conjecture of tetradimensional bodies, a hypothesis or conjecture that would explain the reason for this behavior so foreign to our experience. We refer, mainly, to three very exotic phenomena that occur in our reality.
The first is one of the strangest aspects of quantum physics: entanglement. Let's see. If a particle spins to the right like the green particle in the animation, its antiparticle, the red one, will spin to the left. And this happens regardless of the distance they are separated by. And if we change the spin direction of one, the other will also change its direction instantaneously, as can be observed. It's as if they are communicating with each other. And that communication between them is faster than light, meaning it's instantaneous. And that simply isn't possible in the reality we know. The second strange phenomenon is when a particle can be present in two different places at the same time. This was first verified in the double-slit experiment. In this experiment, individual particles pass through both slits at the same time, then generate an interference pattern on the detection screen. The third phenomenon that our conjecture would explain is the appearance and disappearance of particles in a vacuum. In our three-dimensional reality, it's easy to understand what a vacuum is. It's simply a space where there are no three-dimensional objects. But in the quantum vacuum, particles suddenly start to appear that can be detected for extremely brief moments. In this seemingly empty space, there's actually a constant appearance of particles that quickly fade away. But is it possible for something to emerge from nothing? As three-dimensional beings, living in a three-dimensional space, we assume that our 3D space is all that exists. Could we be misinterpreting this phenomenon? To explain the first phenomenon, let's do the following. Imagine a rod rotating around its longitudinal axis. It has a green end and a red end. The green end rotates counterclockwise, and the red end rotates clockwise. Notice that the rod is a single object, but its ends rotate with opposite spins. Now, if the entire rod changes its rotation direction, causing the green end to rotate to the right and the red end to rotate to the left. Now, let's transform this rod into an inverted U-shape. This object continues to rotate without being affected by the bend. Now we can clearly see that both ends have opposite spins. And if we change the spin of the green end, for example, the red end will also change immediately. Do the green and red ends communicate with each other? Clearly not. There's no need for instantaneous communication because it's a single object. Now, suppose the U-shape object belongs to a three-dimensional space or 3D. How would it appear within a two-dimensional plane or 2D? In a two-dimensional world, the 3D object can only be seen at the intersection of both the 2D plane and the 3D object. Now, how would the 3D object appear when intersecting the 2D plane? The upper part of the inverted U-shape would appear as a point, a particle. Then, if the plane moves or the U-shape moves, the intersection with the plane would show that the particle split into a particle and its antiparticle. The left particle green might have a right spin, while the right particle red spins in the opposite direction. And if one particle changes direction, the other will immediately do the same without the need for communication. Of course, a being living in 2D, a two-dimensional being, would think that the two particles are communicating. And this is not spooky action at a distance. It's just an object, this inverted U-shape, that seems to use its own laws in its own space. It elongates, and the ends separate, continuing to spin. And this way, it continues to confuse beings observing it from the 2D plane. All the above is true if we elevate it by one dimension. Thus, we creatures of the third dimension would see objects like the tetradimensional inverted U. The second phenomenon that seems illogical to us and not understood in our 3D world is when a particle appears simultaneously in two places at once. This phenomenon occurs in nature when an elementary particle simultaneously possesses two states at the same time, such as photons that can appear in two different places at the same time, something we can't imagine in the physical world we know. This has been verified in the double-slit experiment, where particles simultaneously pass through both slits. How is this possible? To explain it, let's imagine that our world is a 3D plane, and the 4D object is the one we shoot at the double slit. We, as three-dimensional beings, can only see what happens in the 3D plane. That's why in the animation, we shade the intersection area of the 3D plane with the 4D object darker. This darker section is what we can see, as anything outside the 3D plane is impossible for us to see. To understand these subtleties better, it's recommended to read Flatland by Edwin Abbott, which is easily available online. What do we observe? First, we shoot a dark point, but then the inverted U shape rises, intersecting two sections of it in the 3D plane. Apparently, an object split into two, but it's an illusion, as it's the same object intersecting the 3D plane in two separate regions. Interestingly, this object naturally intersects the 3D plane in multiple regions. It does so all the time. But we interpret it as if a particle had split into two. Another particle and its antiparticle, spinning in opposite directions. But remember, the rest of the 4D object traveling outside our 3D plane is invisible to us, as seen in the animation. We only see a dark intersection that splits in two, as if it's an object duplicating to invade two places at once. But in reality, it's a single 4D body. The third phenomenon is the existence of particles that appear and disappear. Let's take the case of a 4D object moving in its space. Suddenly, a 3D plane appears, and as always, the object passes through it without difficulty. But what do the inhabitants of that 3D space see? What do three-dimensional beings observe? Outside their own plane, they can't observe anything, as they can't invade a fourth orthogonal axis with their vision. But they can see what happens at the intersection of the 3D plane with the 4D object. They would see the following: a particle that appears and disappears. First, it's a point, then its circumference grows to a maximum before reducing to a singularity. Then it disappears again. The shadow of a 3D object is two-dimensional. But the shadow of a four-dimensional object is three-dimensional, meaning it has volume. And what we would see would actually be that the particles in that intersection region wouldn't be flat, but would have volume, as can be seen below. Remember, in the 4D world, which we don't see, the tetradimensional object is moving. It's only when it intersects with our world, the 3D plane, that we can perceive it. Now we have three 4D objects in different positions. The first fully intersects, and a three-dimensional being would see it completely. The second object only intersects a small upper section, so a three-dimensional being would see a point. The farthest object doesn't intersect the 3D plane at all, so it doesn't exist in a three-dimensional world. It's as if there's nothing. Logically, there's no intersection, so for a three-dimensional being, that 4D object wouldn't exist. It's nothing. Yes, nothing can't be seen because it's not present in the intersection with the 3D world. But if it appears and then disappears, it's because these tetradimensional bodies are constantly crossing our plane. Finally, what shape does the tetradimensional object have? In this conjecture, we've used the shape of the inverted U. But not much can be said about four-dimensional objects themselves. We can only discuss their intersections or the shadows projected into the three-dimensional plane, shadows that have volume. But everything said about the inverted U can also be said about a torus. Notice that if this 4D object changes its rotation direction, then any two ends of the torus that intersect the 3D plane would spin in opposite directions. The red and blue intersections would change simultaneously. There's no need for ghostly communication at a distance because it's a single object. Our system or 3D world is contained within a larger one. The explanation of the three aforementioned phenomena originates from a universe filled with 4D objects that contain us. Let's look at this Venn diagram. These phenomena can't be explained using the elements of our reality. But the solution comes when we consider the conjecture of 4D bodies. This way, phenomena like distant communication, the appearance and disappearance of objects in a vacuum are understood in a more logical manner. The ideas become clearer using the torus of the conjecture. Let's take an example of how solutions and explanations for certain problems often come from larger systems that encompass them. Years ago, in conventional algebra, the solution for the following equation was unknown. X squared plus 1 equals 0. They simply said that this value of x didn't exist, that there was no solution within that algebra system. After some years, they discovered complex numbers, a larger system that encompasses conventional algebra, and it explained it. Finally, the solution was found. X equals the complex number I. Conjecture of the tetradimensional body. Our conjecture of the 4D body shed light on these seemingly illogical events. The first phenomenon we discussed was entanglement. We saw why a particle spinning to the right would cause its antiparticle to spin in the opposite direction. It also explained that the particle and antiparticle are just two opposite aspects of the same thing, and that thing could well be a torus living in the fourth dimension. The second strange phenomenon we discussed was when a particle can be present in two different places at the same time. But as we saw, what actually happens is that the 4D object touches two different places at the same time. The third phenomenon our conjecture examined was the appearance and disappearance of particles in a vacuum. The 4D objects are always in the total space. We only observe them when they come into contact with our 3D plane, our three-dimensional world. The fact that we can't see the 4D objects doesn't create a vacuum. Sure, we think that an area is empty, but that's because there are no 4D objects at the intersection with our 3D plane, which we can see. Some consequences of the conjecture. Let's call it David, who measures and observes. When he closes his eyes, he neither measures nor observes. When he opens them, he measures or observes. In the double-slit experiment, when David closes his eyes, the same particle passes through both slits at the same time. But we know this happens because the 4D body is capable of passing through both slits. And we see two particles because we can only see the intersection of the 4D object with our 3D plane. But when David opens his eyes and measures or observes, the particle's behavior changes, and it only passes through one slit at a time. The strange behavior disappears. Why? The only explanation is that by observing or measuring, David affected the 4D object. What affected it? Clearly, a 4D object can only interact with another 4D object, as they can only affect each other. But we know David is a 3D body. But still, he affected it. That means that David's 3D body has some component that resides in the fourth dimension, and that component manifested when he measured or observed. The interesting thing here is to highlight the fact that David's body isn't a pure 3D body, but has something in the dimension invisible to us. This leads us to another conjecture. Some 3D bodies have 4D components that we don't see, but how does knowing this benefit us? In a subsequent video, we will explain.
As we've seen, the 3D universe is contained in a larger 4D universe. Of course, many physicists assert that the fourth dimension only exists in very small bodies. But we consider this not definitive. If we can do geometry in 3D space, we can also do geometry in a larger 4D space that contains us. 3D bodies are particular cases of 4D bodies, just as conventional algebra is a particular case of complex numbers. Newtonian physics is also a particular case of a larger physics that encompasses it, relativity. We can state something more that's a consequence of all the above. Every 3D body is a 4D body, but not every 4D body is a 3D body. To conclude, it remains only to say that the conjecture of the 4D body changes the paradigm. Yes, I know, imagining the 4D universe is very difficult, but considering that we live in a space formed exclusively of 4 spatial dimensions would change our way of thinking a lot. Goodbye and thank you very much.